Thanks for tuning in again. This is going to be the third example of finding and choosing a good viewing window. In addition to that, I'm also going to show you guys how to find the maximum, the minimum, and any zeros that might be lying in there. Real zeros, of course. In your y equals menu, make sure there's nothing in there except for the following function. And I know part of it we can't see on the screen, so I'll type that in for you and you can see everything that's there. We're going to have x to the fifth minus 7x to the fourth plus 25x cubed minus 40x squared plus 13x. So that's the function that we're going to work with. One of the things that we're going to do is start off by looking at our standard viewing window, zoom 6, to see if there's anything in there we can see. Ooh, yeah. We can see a whole bunch of stuff. Now I can definitely see where it kind of goes up. I don't know where it comes back down, and then somewhere it's going back up. So I'm going to take a look at my x-axis first. I'm going to go from -1 to, let's see, this looks like it's 1, 2, 3, maybe about 3. So I'm going to go to my window settings, and I'm going to go from -1 on my x-axis to 3. And I'm going to leave my x scale at just 1 for right now because I just kind of want to see what that looks like. Okay, cool, check that out. So I can definitely see there's some things going on. Now, if I look at my y-axis right here, I'm going to change that a little bit because I can't see down here on the bottom. I can tell up on the top that it just kind of kee's going, but down here on the bottom, I don't know like where this actually like dips below here, so I need to go lower than where I'm at. So in my window, if I want my y's to drop lower, then I've got to change my y minimum. So I'm going to go down and maybe just change that to -20 for the moment. So -20 is where I'm going to change you to. Then let's take a look and see what that picture does for us. Alright, that's a little bit better. The only thing I'm going to change next, because see all these little tick marks right in here, they just kind of annoy me a little bit. So I'm going to go back to my window, and right here my y scale is 1, so I'm going to change that to 2. And then see what my graph looks like. Alright, that's a little bit better. Now it's starting to be a little bit nicer picture. Over in here, I'm going to go back to my x-axis for a second and check this out. I go from -1, and then I can see that there's definitely 1, 2, 3 zeros. 3 real zeros. So I'm going to sit here and I'm just kind of thinking about this a little bit, where I want to zoom in maybe a little bit more. So on my Windows setting, I'm going to change my scale, my X scale, to 0.5 and just kind of see what that looks like. Maybe it'll make it look better, maybe not so much. Oh, okay, that kind of helps a little bit because check this out. There's a 0 right in here a little bit before 0.5, so maybe it's like 0.4 or something like that. But I know that's going to help me estimate a little bit better when I go to find the zeros. There's going to be 3 things that we're going to do. First thing, now that we've got a decent viewing window, we're going to go ahead and find this spot, our 3 zeros, 1, 2, 3. We're going to find those. We're going to find this spot right here, which will be a maximum, and then we'll find this other spot down here, which will be a minimum. Now the maximum and minimum in these two cases, they're technically called a relative maximum or a relative minimum because they're not the highest or lowest points on the graph. But, you know, kind of getting into some calculus a little bit, if you take a look at this piece right here, and this is where this all ties together. Math is so cool because it does that. If you just take a look at slope, like right here along this side, it's like, oh look, we're going up, so that means our slope's positive. But then all of a sudden it's going to top out and it's going to change direction, and now our slope's going to go down. And when our slope's down, we refer to that as a negative slope. Then it'll bottom out again, and then we're going to change direction, and now our slope's going to be positive as we continue on in our function. So those spots where the slope changes, that's going to be a relative max or a relative minimum. And when you guys take calculus, you'll get into a little bit more rigorous definition of how to actually prove that this is a maximum or a minimum. But for now, let's use our graphing calculator to give us some assistance with that. So the first thing I'm going to do, I know it's somewhere. Now right up here, remember our scale is by 2's. So that looks like it's at 2 right there. So 2 is a little bit higher than where our maximum is. So I'm guessing maybe it's around 1.9, something like that. So let's kind of see how close we are for that. If I take a look at my calculate menu, so second trace, and I'm going to calculate that first spot there was a maximum. I'm going to calculate that maximum. Now my left bound, I know it's between 0 and then this 0.5. So I'm just going to type that in. 0 for my left bound, 0.5 for my right bound, and I can see these two little arrows right up in here. They're definitely, my maximum is within that range, so I'm good to go there, and I just hit enter, and voila, I get an x coordinate of 0.1959, and then I get a y coordinate of 1.1. Wow, I wasn't even close. I was thinking 1.9. So, that's why it's pretty good to have your calculator handy. Gives you a lot more accurate picture for that. So there's my maximum. Now if I want to find my minimum, so now I'm over here. Now remember, each one of these on my x-axis, let me just go back to my window. Each one of those, my scale is 0.5. So if I go back to my graph, because sometimes I've got to do that. So this is every two of them is 1. So that's going to be a half, 1, 1.5 right here, and then 2, and then 2.5. So somewhere between, I got to count again. So that's going to be 1.5 and maybe 2.5. So somewhere between 1.5 and 2.5 is where this minimum is going to be. So if I go to second trace again into my calculate menu, this time I'm going to want number 3, a minimum. So I'm going to select that, and for my left bound I'm going to type in 1.5. Let's kind of see where that puts me. Ooh, check that out. That's pretty close there on the bottom. Instead of actually typing in a number, what I'm going to do is use my cursor, and I want to pay attention to my y coordinates. I want to see when they start to go back up. So I'm dropping them at negative 14.8, negative 14.9. I'm at 15. Ooh, now I'm starting to come back down at negative 14.97. Negative 14.88. So these y values, they're definitely going back up, which means I've passed wherever that minimum is. So I'm good right there, and I'll just hit enter. Guess? I don't have time to guess. I got more things to do. Bam. Let's see what it gives us. Now we get an x coordinate of about 1.76 and a y coordinate of about negative 15. So that's where my minimum is located. So that's pretty cool. So we found a max and a min. Now to find the zeros, that's what we're going to get after next, and there's 3 of them in our graph here. Now I know one of them's right around here. It almost looks like it could be at 0, but it's probably not quite there. So there's one here, and one over here. And what I'm going to take a look at is when I go to calculate my 0, so I'm going to go to second trace, and this time I want number 2, because that's what 0 is. Now let's see where the cursor is. Cursor is way over here. Now if I go over here to the left on my x-axis, negative 0.5, and I type in negative 0.5 for my left bound, I hit enter. Let's see where it puts us. Oh, it's not. I can't even see that on the screen. It must be below where that is. But then if I just kind of, for my right bound, I want to go, and I'm just going to move up little by little by little till I see my y value is now positive. See, now it's positive. And when you take calculus, you'll learn about this thing called the intermediate value theorem. And that just says, hey, if you take a look at something negative and then something positive somewhere, and you have a continuous function, which all polynomials are, somewhere between that negative y value and the positive y value, you got to go through 0. Because 0 won't let you through in a continuous function. You've got to go through 0. So what we're looking at is our left bound is going to be a negative number, and then our right bound in this case is going to be a positive number. So we're looking at the y equals value. So now that we have a positive, we're just going to hit enter and guess no, because we got things to do. Ooh, yeah, check it out. Look, it was at 0, 0. Hey, we were right. So that's pretty cool. So we found that one. And then we're going to repeat the process for the other 2 zeros. And again, our function's continuous. So somewhere over here, a little bit before 0.5, it's going to be positive, and then it's going to change to negative. So I'm going to hit the trace button. Now when I'm using this trace feature, what I want to do is get as close as I can on the positive side of y. So check it out, I'm at 0.19. Ooh, then it changes to negative 0.2. So right there, that's where I want to start calculating my 0 from that spot. So I go to second, calc, and then I want a 0, and it's going to be right where my cursor was at that left bound of x equals 0.4 and y equals 0.19. So I'm just going to enter there, and then the right bound, all I have to do is hit my arrow once, and look at that. Our y value is already just a little bit below the x-axis. So what I'm going to do is just hit enter, guess, I don't have time, boom, booyah, check it out. We get about 0.42. So somewhere at about 0.42 there's a 0. Now notice this time we did get a y value of 0. Now I've got one more 0 to find. Now something got messed up on my calculator. I don't know what my window was set at, so I'm going to change it back to this just so so I can kind of see everything that's going on. I'm actually going to change the y maximum to say maybe 8. I forget what I had it at before, but so when I take a look at this picture, I can definitely see where this other 0 is right here. Now don't forget, let me go back to my window for a second. Every tick mark on my x-axis is a half or 0.5. So when I look at my picture, that's every 2 of these is 1. So half, 1, 1.5, 2, 2.5. So a little bit after x equals 2.5 is where that last 0 is going to be. So, and again, what I'm going to do is use my trace feature. Now notice I'm all the way down here, so I'm going to use the right arrow key and get as close as I can to that x-axis. Now the closest y value that I get to is negative 4.3. Yours might be a little bit different depending on your viewing window and how your trace feature is working, but then I'm going to use that as my starting point. So I'm going to go to second and then calc, or second trace, and I want to calculate a 0. So my left bound, I'm going to start right there. Notice the cursor's blinking right there at where we left it. So we're just going to hit enter, and then for our right bound, we're just going to go 1 right above it. Bam! And then once we have that, because notice our area right in there, the intermediate value theorem says if I go between a negative and a positive, I've got to cross 0. So guess? Nah. We know we're going to get a 0 in there, and check it out. We get about 2.56. So those are our 3 zeros that we came up with, and we came up with our maximum and our minimum. That wasn't so bad, was it? It's tedious. It's a lot of button pushing, but you guys are in an upper level math class, so you can handle this. Alright, so thanks for watching. Hopefully you enjoyed all of this and you know how to use your calculator to help you find all these values now. And that's all you got to do for this. Peace. I'll see you guys around.